Hello, welcome to Show Me SaaS today. We're joined again by the my traditional partners in crime here. Toby, Bill, you want to wave hi here and say hello, or not wave hi, but Bill, that is your call. Put him on the spot. I really appreciate you joining the show today. We're going to talk about a topic that on the surface may not seem all that glamorous or all that essential to SaaS, and except for me, in fact, this notion of tenant tiering and tier-based throttling, and that we're going to talk about today, is often like just fundamentally a core to SaaS environments, because it's partly about keeping the lights on and being sure that you can scale your business effectively without tenants sort of saturating your system in ways you don't expect. And it's also connected to this whole sort of notion of how we might want to provide different experiences to different customers. And this all is sort of derived from this notion of when we have multi-tenant environments and we start sharing resources and we have new tenants joining all the time, and the sort of footprint of our environment is constantly changing on a day-to-day basis. Even how people are consuming our system is potentially changing on a day-to-day basis. We have to put in levers and mechanisms to be able to say, what happens if they do something I didn't expect? They consume the system in a way I didn't anticipate. And how can I be sure that I put some kind of controls around that to be sure that they don't somehow just bring the system to its knees, or potentially have a negative impact on somebody else who's consuming the system? And so that's the spirit of the discussion today, is really this whole idea of throttling, which, if you're not used to the idea of throttling, we're really just talking about what policies we can put in place across the whole surface of our application to detect and limit somebody's ability to put unexpected load on our system, or load that might have a negative impact on the environment. And we're connecting that to the idea of tiering today as well, which is we offer basic, advanced, premium. We offer different flavors of tiers to our different customers. And these all are sort of intertwined around this idea of controlling the experience. But I think before we get into like different ways you might implement this, I do want to at least just level set a little bit. I'll throw this slide up here. It's really basic, and just say there are two very different sort of notions at what it means to tier or to throttle in these environments, or maybe two different motives would be a better way to say this, right? Which is there's a business notion of tiering, which is more like, hey, I have a very specific set of pricing models. I have a very specific set of customer experiences I'm trying to promote, and I'm drawing hard lines between those with tiers, and I have to implement the policies to make sure that happens. And then there's even if I don't have that whole tiering sort of notion, there's just and I need a better word for this, but for this slide, I called it operational durability, which is just like, how do I make sure I'm scaling? How do I make sure that the availability of the system stays online? And I don't know. I mean, maybe I don't even know if this is the right distinction, the line between these things. I don't know, Bill or Toby. Does this make sense as a way to split it? I know we didn't talk about this ahead of time, but and maybe there's a better terms to use here.
I feel like there's probably another dimension that might be captured in those blue boxes. But one of the things that occurs to me as a SaaS provider, you're always caring about your margins, right? And if you've somehow got the ability for a tenant to run away with your costs, such that you stop making money, that would be something I'd care about, right? And so just we don't call it out explicitly here, but maybe it is worth calling out that if you don't keep them in a box such that your own costs are under control and predictable and that kind of stuff, that might also be a factor.
Yeah, that's a huge one. I tell a story in another presentation I have done. So it's weird that I didn't put cost on here because in my other story about tiering, I talk about the time I worked at an e-commerce company, and we had all these sort of basic tier tenants who didn't pay us an awful lot of money, who were just consuming our infrastructure like there was no tomorrow. They were just putting a massive load on our system, and they were driving most of our cost. because they were doing all these crazy things because they were experimenting and pushing the system and doing nutty things we didn't expect they would do. And then the advanced tier, who are like our premium bread and butter, that's where our revenue is coming from, weren't pushing the infrastructure nearly as hard. So we had this cost infrastructure mismatch that we needed tiering around. So I actually think that's a really good call out, Toby. So thanks for making me look bad for leaving one out here.
That's what I do, Todd.
But that's why you're here, and I know that. But yeah, I do think that's key to this story. In fact, I would say it's an often overlooked piece that I think people build SaaS products and they almost don't. They just sort of treat the infrastructure as a foundational thing you're supposed to have, and they will in fact introduce features and function to their product. I remember we added a feature that required us to suddenly capture all this new analytics data. And suddenly we had this huge, big footprint of data we didn't have in our solution before. And the cost of our infrastructure went up, but nobody on the product management side, nobody who thought about adding that feature wondered about what that would do to the cost footprint of the application.
Yeah. Todd, I'm going to forgive you for leaving cost off here because I'm going to tie it to tiering and we'll try to
make me look good. That's all I care about here.
We'll try to fold it all in here and see what happens. But I think in some ways I mean, Toby, you're absolutely right to call it out. Having some sort of guardrails around your pricing structure is important. I think what I'd like to do though is maybe just tie that to tiering and say, okay, if you are assuming you're going to have some form of price tiering, one of the things I've run into with some partners is if you set up these price tiers, you also have to build both SLAs and guardrails into those tiers. Just a concrete example of somebody I worked with in the legal field who were using a lot of AI ML services. And on they're on a consumption basis, those are relatively inexpensive. But if you start taking a whole bunch of documents and you start feeding them through all of these AI ML services, it adds up in a hurry. So because they were in the legal field, they were expecting customers to use them, translation, for example, with irregularity, right? So they would say, okay, we might get occasionally some documents that need to be translated. Well, they got a couple customers who started operating in APJ in Japan specifically, and all of a sudden, all of their documents were being translated, and they hadn't put any sort of guardrails into their price tier. So those customers became wildly unprofitable for them, and they didn't have anything built into the language of their agreements saying what the customers could and couldn't do. So Todd, just tying those two things together, I think there is a cost element to this. If you are lucky, that can just feed into your tiering strategy, right? And so we'll pretend that we thought of that and we put that into the tiering strategy.
I like where you're going there, Bill. That makes me look better. But maybe now when I think about that, and I think you did a good job explaining that, is that my motive for building tiering isn't just about a revenue strategy and a stratification strategy. It's also about a cost control strategy, right?
Yes.
And so if we say it that way, I don't need a third box, and then that makes Toby his point no longer valid. So in that mode, I think I'm comfortable with that.
Right.
So thanks for the bridge there, Bill. But let me ask this question, and I'm genuine in asking, because we talk about this all the time across the, you got to have tiering, it's essential, blah, blah, blah. But there are systems that aren't tiered out there. People don't have tiers, they just sign up. And there are people who are, sorry, I just realized I got a battery issue. Let me just plug in my battery before this gets to be a bad moment. Plug in there we go.
This is when that hold music should play during the.
I think so. Yes. Please pause for a moment. There are people who just they don't noisy neighbor, whatever it is. They're just our infrastructure, our scaling, whatever we've got has to deal with that. So I guess I'm posing the question, either tiering, operational durability, whatever your mindset is there environments for SaaS where throttling doesn't matter? You don't need throttling policies. You don't need to sort of detect and do anything with this.
Yeah, that's a good question. I think I might even change the wording a little bit from, I've run into some scenarios where it isn't that it doesn't matter, but it actually may be a huge negative to the customers, in some way impacting customer experience in a huge negative way if you do any throttling at all. For an example, a random example, if you were in the medical device field, it may seem tempting to say, well, if we get bombarded with requests, we're going to start to throttle them. But you're talking about possibly life-saving devices, right? And to start to throttle somebody's requests in for devices that are critical to some form of operation, whether that's manufacturing or healthcare, whatever that is, you may simply be in a position of having to support that. Even if customers make a mistake and bombard you, you have to be able to scale and meet that demand, because you don't know what you might be throttling if you did throttle.
Yeah. Yeah. I guess that to me, it's not invalid to not have throttling, but I'm also having trouble imagining scenarios where even if it just out of no matter, maybe that throttle's set really high, but there's some barrier at which if the choice is the system comes down and all tenants go down, or the lights stay on. I mean, this is back to circuit breakers and all these things. And Netflix has all kinds of cool stuff around this, where there's a point at which no matter what, if you're going to keep the lights on, you've hit some threshold. We've got no choice. It's not good. So I guess for me, that's the baseline version of something you ought to be doing. And then you're right. I might still mean, if I'm having that happen, that may mean for your example, I need to add more capacity right away to make sure that never happens again. But at least I want to detect it.
It also probably depends on your pricing, right? Like if you're priced in such a way that it is like AWS, right, per unit of consumption or something like that, and you want, assuming that you've got the ability to bill and do all that stuff already in place, and they want to run up a bill that is based on their consumption, that might, you wouldn't, unless, again, if the throttling, if the pricing tier was such that, hey, you buy 1,000 of these, whatever they are, or ahead of time, then that's different than say it's on demand. You plug your hairdryer into the wall and you get power, right? It's a different model.
Yeah, I worked with a customer who was in the publishing space, and in the publishing space, they build entirely on bandwidth, and their whole solution was built on bandwidth. And for them, they felt there was a strong enough correlation between bandwidth and their infrastructure footprint that they thought that was a reasonable mapping. So they had no tiering at the time. I don't think they did. I think they might have added tiering at some point, but they were comfortable that they had some expression of consumption there. Now, I think they still had throttling underneath the hood in some scenarios to make sure they had good availability. But So anyway, I think that's I guess for me, we're going to talk about this, but I don't want to presume that means every single system is going to implement tiers and every single system is going to do everything we say here. I just don't know how you can't have some baseline at which you have to do something.
I think, Todd, there's one other aspect I'd want to throw in, which is your architecture, right? So if you were in a completely pooled model and one tenant could potentially interrupt your entire system of all of your other tenants, it's a different blast radius than if you've built silo SaaS, right? Where you might be able to nuke your own environment, but at least for most of the structure for other tenants, there's a strong isolation between them. So again, that might come back into play for if you find yourself in a field where you have to support all of your tenants' traffic all of the time without baselines. Maybe you need to think about how that reflected in your architecture in addition to how it's reflected in your tiering.
I definitely think your silo versus pool point is a good one there, right? I mean, a lot of what we're going to talk about here is definitely leans more towards the pool side of this discussion, because the more things are shared, the more this becomes a problem. I think you just end up with more coarse-grained notions of tiers or of throttling here as you move towards more siloed resources.
Right.
But even then, you can have siloed resources that could have tiered policies. For example, I could have a DynamoDB table per tenant, and I could have those tenants be different tiers, and I could have different read-write sort of policies for those. Even though they're siloed tables, they still have different levels of access and throughput.
100%.
Cool. That was more meaningful than I thought, and I escaped needing the third box, so that's all good. So I also wanted to just highlight the fact that this where throttling happens isn't sort of just this one sort of entry point, one border of your application, and then you're done. I think it gets implemented that way a lot, right? Like we see here, I've got some API entry point to my application. And yes, API gateway, API tooling gives me all kinds of good throttling mechanisms. And clearly, if I can catch this at the front door, I want to catch it at the front door because that will prevent any downstream sort of challenges. But I will say that doesn't mean that you shouldn't necessarily have throttling mechanisms all the way down into the application components here. The application services, the microservices of your application may also have their own throttling constructs. And then as those microservices interact with other dependent resources, if I'm interacting, like I said, DynamoDB, or if I'm working with a queue, or I'm working with some other resource, I may have to think about whether or not how I'm going to consume that resource. And is there some way that I could saturate the use of that resource? And I would say at the API state of this, you could probably split it in two and say there's the application's potential consumption of the API, and then there's an actual potential developer API experience here. And they both need throttling, but they might be different experiences. I guess these are I felt like these were the hand-wavy high-level versions, at least, of where you might do this. Are there nuances to this that I'm missing? Because Toby, this is a chance to highlight a need for another box, I think.
No, I mean, at first blush anyway, I think this makes sense. I don't know. I haven't given this a whole lot of careful thought.
Cool.
I think to some extent, your dependent resources boxes could be very encompassing. I've run into some very strange downstream noisy neighbor problems where APIs like the AWS APIs, for example, where tenants coming in can actually cause the microservices to start calling AWS APIs and potentially, with account limits, started to cause some traffic jams with other tenants making similar calls in. So sometimes those downstream effects, like you're describing, aren't apparent, and you couldn't block them at the front door, because it's only after the fact, when they start hitting some of these downstream resources, that they even become apparent.
Yeah, if we take the simplest example there, right? Like the number of requests coming into the API they're not reaching a level that's a problem. But then I get into some microservice, and then the microservice is doing some batchy operation that suddenly is like thrashing the CPU or thrashing some other resource. I might not detect it till then.
Yeah, exactly. So I think it encompasses it really nicely with that dependent resource box, because that could be all sorts of things, and you won't really know at that front door until you find out there at the end.
Yeah, and I will say also that there are different how this even lands across different bits of the stack could be different, right? So I've just pulled up this is a serverless sort of notion, right? And if I had tiered solutions across the compute, so now I'm beyond the API, I'm down in some microservice, and that microservice is processing requests. I might actually be applying tiering strategies or throttling strategies all the way down at this level. And in this case, you have this notion of reserved concurrency with Lambda. And Lambda will let me create so basically how many concurrent executions of a function. I'm sure there's a better definition of that, but that probably somebody who's really deep in it would say it's more than that. But at a minimum, that's a good mental model for it. And here I can say, hey, my basic tier tenants, I don't want them just like totally consuming all the concurrency for all my Lambda space. So I'm gonna give some of the limited set of reserved concurrency to them, give advanced tier a little more, and then give everything else to my premium tier tenants. And I think that I just want to highlight that. And then if we look at, just for contrast, look at like something with containers here and EKS. EKS gives me all kinds of cool knobs and dials for all the way down to the compute level here, saying what kind of quotas there are, how is the CPU, how these things going to scale. I don't know, and Toby, I'm going to put you on the spot because I don't know that I know the answer. You may not as well. Will the quotas actually act like throttling here, in that if you exceed the quota, they'll stop taking requests?
It'll actually kill the container.
Is that what it does?
Yeah, it'll evict the container.
And what is the net effect of that? That essentially I've saturated one container, And so it's taking it away and then sending that load to the others. And then I'll just start slowly saturating the others as well if I don't have enough, or will it scale?
Yeah, well, you'd want to obviously kind of couple this with scaling, right? So that you distribute the load a little bit. But I think the idea is that these guys are stateless, and so one of them starts getting a request, and for whatever reason, let's say has an unbounded process that just kind of runs away. It would just evict the container once it hit that limit, and then restart it. And if assuming it's now, obviously there might be downstream or there might be upstream effects of that. The user who had that runaway process or might experience some kind of degraded state of the application. But from an overall perspective, those it just kind of keeps the pods in check.
So it's more about the health of the container here, basically saying, hey, you've exceeded the limits of this particular container, so I'm going to evict it. Just because we're just going to bottleneck or some other bad side effect is going to happen. Yeah. But I can still, through policies, configure when they get evicted. So I was trying to figure out how that, and I'm probably putting questions out there for which there may not be clear answers, but how does that relate to the sort of traditional notion of throttling? Because really this feels more like, no, I'm going to stop processing those requests. But the reality is whoever's generating those requests, they might now go to another container and I might immediately saturate that one, right?
Well, I think you'd have to kind of dovetail this with some kind of ingress or a Kong or an API gateway, right? That is, at one API call represents some number of internal service calls. And so if you can kind of do the math and like you said, get ahead of it at the front door, that would be, I think, still the desired approach here.
Cool. So
to your point, I think that the quotas in this case are more about just ensuring noisy neighbor issues are addressed in the event they weren't addressed at the front door.
Got you. So let me ask the harder question of this, and I feel like I may be posing more problems than solutions today, but like imagine you detect one of these events, right? Like you're somewhere deep it's better to have this example further down in the architecture. It's one of those layers a little deeper that I detect something's broken. You've exceeded the quota. The system says I'm not going to process this request from you. What should we tell developers to do as a way of surfacing that back to the consumer, or the generator of that event, if you will? Is it just stops processing, and whatever I get back in the application that is interacting with this gets some ugly failure sort of message, or are we suggesting that when one of these throttling events happens, that I should have some graceful way to cascade that back out to the users so that they have some notion of, hey, you've exceeded your throttle or you've exceeded your tier's capabilities?
I mean, you look at API Gateway, right? You're getting a 429, exceeded your limits.
Yeah.
That's a pretty big hammer though.
Right.
That is.
Well, it is and it isn't too, though, right, Toby? Because I mean, hopefully, fingers crossed, hopefully you have on the other end of that somebody sitting there listening to those 429s being like, aha, I should retry this. Or, okay, the 429 means I need to raise some alerts in the system telling people like, hey, we need to stop doing what we're doing. But you're right. I mean, those 429s, if they're not handled, then things just stopped working. And hey, why doesn't my SaaS work anymore, right? But probably more common, right? Go ahead,
but let's go. I mean, I think the API gateway is good, but assuming I didn't get throttled at the API gateway, I got through, I'm in the microservice, and now EKS, I hit the quota, I hit the concurrency limit inside of my Lambda function. Like they're not necessarily going to send they don't know they're even in an HTTP sort of request process necessarily. Like, do I have to use frameworks or tools or mechanisms? Like, this is where you'll see circuit breakers, you'll see fallbacks, you'll see other things where like maybe the request fails and you have a fallback strategy that does send back an HTTP response or something that says, yeah, you failed for this reason. Like, it feels like if you're going to invest in this, you can't just invest in the detection of it. You've also got to invest in the some kind of graceful. It doesn't have to be super graceful, but some way that when it goes back, the caller has some notion of what went wrong.
Now that I'm thinking about this, I don't know that there's any good way. Like, obviously resource quotas and that kind of, and even reserve concurrency, that kind of stuff on the Lambda layer stuff, or in the Lambda layer would be like, you want those just for what you said, the health of the system, right? Like, you don't want to you want to make sure that it just doesn't all get torn down, or fall apart. But at some point, assuming your calls are asynchronous, and maybe I'm getting too far in the weeds here, but assuming you've got the ability to kind of batch stuff up and you're filling up a queue, and that queue just isn't draining at a rate that represents success, right? That every minute goes by, more and more stuff is in the queue. Like, what's the answer for that? Like, I don't know. Like, you've reached your throttling limits, right? Like, you can't hit more. So do you just say that it's just a degraded experience, that what would be a sub-second operation is now 5 seconds, and just that's the cost of doing business here?
Yeah, it's a fair question, because certainly degraded experience is probably not something like, as long as it eventually succeeds, you could just say, well, that's the performance you get based on the tier you're in or whatever, right? That all works for me. But I'm thinking of and maybe I've just got my old mappings to Netflix stuff too wired into my head. But like, I remember Netflix showing these diagrams of, hey, here's a request to go to do something with the system. And here, 12 levels deep, this microservice called this microservice called this microservice, and then that microservice fails. If you're waiting on the success of that, like, you bottleneck the whole system. That's a whole separate issue, a design issue that doesn't have anything to do with the throttling. But nested in that is the idea that it is back to async, like you talked about, Toby. Mm-hmm. I think you almost, if you really want to handle these things gracefully, you've got to commit to some more elaborate async model that says, hey, I'm going to ask this service to do something. And if it either doesn't come back in a certain amount of time, or it tells me that it failed for some reason, I have defined the mechanism by which that will bubble to the surface, and at least won't break the rest of the system.
Yeah, there's a great I went through kind of an Istio, I don't know if it was a tutorial. I think it's actually on their site. They go through this whole book example, and they have a little simple page that has some reviews and something else, and they're all different microservices that all get aggregated on this page, and they're going through this circuit breaker pattern, right, where it's like, hey, we're going to set tolerations for how long we're willing to wait for these things, and at some point, and maybe there's retry. That's all again built into Istio, which is kind of cool. There's retry logic where you could say if it's under a certain amount, go ahead and try it again. But the net effect of it is, on that page, you'll see certain services pop in just as expected, and another service is just kind of sitting there with a spinner for a second, and finally says, "Hey, sorry, refresh your page or come back later. We're having a moment."
Yeah, I think it's probably a rat hole for us, but at the same time, I do think if you're going to bite off this subject, especially the like beyond the API gateway sort of version of this, you are going to find yourself wandering into like the microservices best practices world of, hey, are the async communications in these? Do you have fallbacks? Are you, where's your, where's the boundaries of between the interactions between all these things, and how do they unwind in some way successfully? But that's probably a little bit about throttling, but it's probably more about just async interaction between services. I do want to. The other part of this I want to talk about before we look at some of the code here is that I'm curious. Like, so I implement throttling, I implement tiering, whatever I implement. And we always say, we've said it even in our other episodes, we've got to have metrics and analytics. We've got to have these dashboards that give us some sense of what's going under the hood. To what extent do you think these mechanisms you put in place should be monitored and managed and sort of proactively watched by the business? Do you see that as sort of a key piece of the puzzle, or something sort of optional?
I mean, just thinking about it holistically, I don't think it's optional at all, right? I think if you're going to go through this trouble of saying, hey, we're going to throttle specific tenants in specific circumstances, one, operationally, if I'm responsible for the health of this the system, I want to make sure I understand exactly who is throttled and when and why. What were the underlying circumstances that caused them to be throttled? Was it our problem? Was it their problem? Was it a malicious attack? Was it like what is the circumstances? Because there's a lot of information buried in any given throttling. I mean, when I've talked to customers about throttling, the thing that's come up the most often is not what you'd expect. It's someone accidentally causing thrash on a system, right? Someone wrote a little script that was designed to retrieve some piece of information from a SaaS platform, and oops, now that's running on a continual loop, pounding on your system, right? Not malicious activity, not usual behavior, just something unexpected that somebody did. And if you aren't tracking those, it's probably going to happen over and over again, or it's going to keep happening until that user identifies the problem, right? Or you're just so one, operationally, I want to understand that. Two, and this kind of gets a little deeper outside of this topic. I want my tenants to also be able to observe their own behavior. I want a tenant admin to also be able to say, well, we've signed up for this SLA and saying, we will throttle the system if this happens. As a tenant admin, I'd like to know when that happens. I'd like to know how often my users are seeing that. And that should also possibly go into a land and expand strategy, right? If you have the visibility where someone who's administering the system for the tenant can say, ooh, we paid for the silver system, but 2 times a day my users aren't able to do their jobs because we're getting throttled. Well, that's a nice upsell mechanism, right? Maybe you should go buy that gold package like we told you to in the first place, right? So it's just, it feeds into a couple different aspects, right? It feeds into my own admins and those tenant admins, and if I could give them both visibility, I think it's better for everybody.
Yeah, so for me, I feel like anytime I'm going to go to the trouble of building these policies under the hood that are like important policies, they're enforcing some experience of my tenants, or they're a key part of my availability story. I would like, if I just had auto scaling, right? I didn't even have this. We just talked about auto scaling, and I wanted to know when the system was auto scaling. I'd want to know when that's happening and why, and what kind of loads are making that happen. I see this as a variation of that, which is I put all these tiering and throttling policies into place. I want to know when people are running up against them and are they detecting the right things? Is the system responding the right way when they do? And like for me, I might discover that the way I tiered my system wasn't a good way to tier it. Like I thought my basic tier tenants were going to consume the system this way, and that I put them in the right box. But then when I look at my operational dashboard, I realize, they never run up against these thresholds. Instead, they run up against these other thresholds that I never even realized they ran up against. And then also for me, like if there are things people are doing that are like approaching some moment where they could cripple the system, hopefully the policy's stopping it, but I still want to know that's happening, because what happens if they leak through in some way that I didn't know about? I'd proactively want to look like, people in this tier are going like close to red or close to being throttled every time they do X or they do Y. I just felt like that sort of would be survival to me in the SaaS world, because to me, you're like, I don't want to be the person whose pager goes off, or who's like got to put that notice out to all my tenants to say, hey, we're in maintenance mode because something broke, or we're spinning something back up. That's just not it's a bad customer experience, but it's like selfishly as the tech guy, I just don't want to be the guy who gets singled out for that moment either. Right. So for me, I guess I worry that in the theme of everything we talk about around metrics and analytics and dashboards, and we beat this to death in our previous discussions of metrics. Like this is another one where I'm like, I don't know how people are surviving without it, but I also see a lot of people without it. So it's like in that category, maybe I'm being judgmental or something, but
well, it kind of feels like, when having been in startups, what you focus on a lot is your secret sauce, right? And the value that you bring and that kind of stuff. So it does feel like a day 2 type thing. But, as you said, if the good thing for the business happens, that could represent bad things for the business, right? So
Right.
you got to make sure you temper
Yeah,
it.
part of me, I guess maybe I think about SaaS like I think of, okay, cloud providers gave me all this goodness. They gave me these dynamic environments, these scalability, these operational bits, these managed services, where a whole bunch of the stuff I used to have to chase operationally, I don't have to worry about it anymore. Awesome. But then there's a point at which I own, as the SaaS application builder, some responsibility of saying, okay, now my app's running on that, but there's a layer which I only know whether or not you're running up against some barrier that AWS isn't going to, or the cloud provider isn't going to be able to detect for me. I have to own that responsibility. But if I get that right, I still get the same goodness I get out of consuming those other managed services, which is they give me data to tell me how they're behaving. I can proactively sort of manage and think about them in a way that keeps the lights on all the time. And I'm not constantly sort of just chasing the next thing that's broken. I think that's super important, by the way, when you introduce new features and functions, right? Because sometimes you put something new out and that new thing suddenly has people using the system in a way you didn't expect. And suddenly you're like, oh man, we're falling down because this new feature is getting pushed in a way we never expected.
I think that's also where the stuff we talked about earlier would come into play, right? Like you've got some algorithm or something that's out there that hasn't been battle tested, and all of a sudden you start seeing that your pods are getting evicted because this thing's going crazy or whatever, right? Like that would be another opportunity to optimize or figure that out.
Yeah. Okay. So maybe I think hopefully we didn't go too far there, but a little soapboxy moment there maybe. But I guess for me, I'm thinking of self-preservation every time I get into that operational mode. I selfishly want to have the tools that keep my team from technically being like feeling like their hair's on fire all the time. And I feel like, especially like at startups or if SaaS is triggering some massive growth in your business, like you're gonna see these things hitting you left and right. Okay, so I'm now going to pivot to the serverless SaaS reference architecture. That's an example we have. We've talked about this a little more, but I want to look at it entirely through the lens of tiering. And before I jump into the code of this, I will say, a key piece of choosing a tenant tiering strategy is how do I map tenants to tiers, and how does that tier context get reflected through my architecture in a way that I can connect a policy to it or connect something to it that would give one tenant a different experience potentially than another. So let me change my sharing here and see if this works. Hopefully that's legible. So just for a little bit of context here, this is an open source serverless SaaS reference architecture that we have out there, and it's an end-to-end working serverless SaaS solution. We've talked about it, how it's used in different contexts. You can go to the repo and download and clone this and have the whole thing up and running. But one of the interesting things that was done inside this reference architecture was that the team, actually, hang on, I'm going to remove, I had one more slide I wanted to share here. The team did implement a tiering strategy, and they did this because it's a Lambda-based model. Lambda sort of API gateway is a really natural way, at least, to implement that top layer of tiering. So they support a range of different tiers in here, and they offer different experiences to those tiers, including siloed infrastructure versus pooled infrastructure, so on. And the way that's essentially implemented is the API gateway has this notion of what's called a custom authorizer. So essentially on each request that's processed by the gateway, I can inspect the request, get the context of the tenant and all those other goodies, and affect the flow of that request, deny it, throttle it, whatever I'm going to do to it. And so in that authorizer, we're essentially going to say, hey, I'm processing a request. I'm going to go out, figure out how a given tenant maps to a tier and how that tier ends up mapping to an API key. We'll get back to the API key in a minute. But the key part of this, no pun intended, of the API key, I'll say that word about 16 times, is that it also connects us with an authorizer policy that maps us to what's called a usage plan. And the usage plan is the real bread and butter of this. This is where the burst rate and the the quota, and those other sort of variables that we get to configure about our tiering policy get expressed. So the sort of maybe the Reader's Digest version of that path is I hit the authorizer, it consults a custom authorizer that gets me mapped to which API key is, and then that API key gets me connected to a specific usage plan, and then that usage plan ends up enforcing my my throttling strategy on a tier by tier basis. Now, one really interesting sort of dimension of this is this particular model only has an API key for each tier. So there's no API key given to the application. So the caller making a request into the API gateway here isn't passing a key and then that key is being used. That is a mechanism. We have other sample code that uses that approach. That approach does mean that you've got to essentially give keys to every customer when they're onboarded. You got to think about how many keys you can have and how that's going to scale. And there's some management complexity of that. Nothing hard or bad about that. It's done all day long for people who use APIs, hand out API keys all the time to developers as the way to do that. So it's not that it's a bad way to do it, but I do think it was kind of creative here where they said, hey, we won't even give an API key to the client. We'll, under the hood, because we have this custom authorizer, we'll do that mapping of your tenant to your API key. And then that means we don't have to have a whole bunch of API keys in the system.
So let's break that down, because I think you're glossing over that as if it's is simple. I'm finding it a little hard to digest. So a request comes in from a client that's just say a web page running in CloudFront.
Sure, some single page application calling the API gateway.
Hits API gateway. There's a hook effectively that is a Lambda authorizer that gets punted off to Lambda. Lambda then looks up something based on the origin or something based
the
on
JOT.
the
JOT has passed tenant context into the authorizer.
So the JOT now is being unpacked by Lambda. Lambda goes and looks up the appropriate key for that tenant, and then calls API gateway again with that.
Yeah, so this is where the code's going to explain this, right? So ultimately, when we end up processing that call, we'll be processing that call in the context of an API key, but I'm going to show you the secret sauce of how that API key didn't have to be at the entry point from the application. Instead, we can tell API gateway, we're gonna treat this request as if it came from a caller using this API key, and then gateway will just say, oh, what usage plan do I attach to that as well?
Oh, so it's not necessarily a recycling of that call back through the front door.
No, and that is the bit I wanted to highlight that I think is kind of cool and clever in this. But that's the end-to-end experience. I think one of the fair questions to ask of this is there too much latency in this? Is the effort to resolve this? I think that's a trade-off of this model. Now, there's things you could do to cache. You could do things to keep this authorizer, efficient. But that's certainly not as efficient as, hey, the caller just in the single page application called me with their API key and I just applied the usage plan and I didn't need all those other moving parts. Cool. So let's remove that. Let's go back to this and let's look at, so I'm going to start by looking at this. There's this big tenant template YAML that's part of this. We won't go through the entire life cycle of this, but essentially, as part of configuring my API gateway, one of the things I configure is this notion of this authorizer. I can set up the API key source. And this is the secret sauce trick that you get to use with an API gateway to say, hey, the source of this request will actually be the authorizer, my custom authorizer. So this is where I get to tell it, instead of just taking the source from where it originally came from, whoever the client was, I'm going to treat the source and the context injected by the authorizer as my source. So this is where the API key essentially can be injected in that same single request instead of reprocessing the request or something of that nature. Does that make sense?
Yeah, I think so.
Cool. So once I've got my API gateway configured this way and I tell it this source is essentially this authorizer scheme, now when I go over and look at like a tenant signing up, right? Now I can say, oh, what tier did they sign up for? This is where I filled out some form and I said, am I basic, am I advanced, and so on. And here I'll essentially, I've got these predefined keys, premium, platinum, etc., basic, that are sort of global keys, if you will, that get assigned, and then they get put into the tenant details. This is just some structure here that is a structure that's holding all these attributes. And now when I go over to tenant management, this is a separate service, and I go to this call to DynamoDB, I'm essentially, so nothing exotic here at all. I've given you my tenant sign up form. I, under the hood, said, oh, you signed up for this plan, so I'm going to go include this API key in your data, and I'll persist that data to DynamoDB. And so if you think back to that diagram where we were resolving in the authorizer the tenant to their API key, this DynamoDB table is essentially going to be where that mapping lives. So now if I go over to my authorizer and I actually look at my authorizer, you'll see here in this authorizer, we essentially set up the classic sort of things you would do where we're setting up this auth policy. And as part of setting up this auth policy, it's all the normal things you would set up. We're not going to dig into all the weeds of those bits. But we've also been able in this auth policy to crack open and resolve your JOT token to get to a tenant ID. So we've pulled the JOT token apart and validated the JOT token and got the tenant ID out of that. So now when I look in the response out of all that stuff, I can go grab the user role, the tenant ID, all that happens kind of going backwards here to give you that. When I pull this JOT apart, I get this response, and now I can actually go pull the tenant ID out of that response. So now one of the things you'll see here is that one of the attributes in that we pass back, we'll build this auth response with we'll call policy.build. That gives us this auth response. That is the response object we're going to pass back. And then down here in the auth response, you'll see we set all this context. We put this context in. And one of the key things is this auth response usage identifier key is the API key. So essentially we've gone cracked open the JOT, declared this auth policy, populated the auth policy with the bits we want to do here, and then also populated it with the API key that we pulled out of DynamoDB and got that context. And now when this API key is in here and we've configured the authorizer back here at the beginning as the source, then it's just magically applies the API key. So now when I make that request, if we go back to technical difficulties here, let's go back to this. If we go back to this view of the universe, now each request that's going through here will essentially get throttled based on the configuration of your policy. So here we've set up different usage plans. Oh, don't click there. Different usage plans that essentially have different configurations for the different tiers of the system. And the nice part of this is if you said, I want another tier, I want to add a new tier to the system, you literally can introduce one new API key, one new usage plan, and then map that API key to, make sure that API key essentially maps to that usage plan, and all the rest of the mechanics just work. So I think that's kind of cool. But I think this is still just the beginnings of what it means to implement a full tiering strategy. I don't think what's missing is the cool code that would now happen at the microservice level here and some of the other stuff that has to happen downstream. I wish I could say that our team has tackled all of those issues. The reality is I think we're still kind of more at the API gateway with our thinking around throttling. I think I do think the different stacks also, like Istio and a lot of the bits of the container universe can get pretty exotic. Even in the container space, if you're not using API gateway, there's a ton of sort of entry points you can use to your container universe, all of which have their own throttling mechanisms. Mm-hmm. So what I think you have to do in that is like look at each one of those and say, how do I map a tier or some notion of a tenant to what the policies are for that particular type of gateway. So I guess for either one of you guys, did that sort of follow? Or Toby, I know I sort of, you had questions there. Did that make sense?
No, I think from the serverless side, I think it makes sense. I'll add a comment to the container stuff. We had a demo recently, internal, from a company, Kyverno, that was doing some really interesting stuff in this space. And I think their tagline, if you go to their site, is something like, we operationalize Kubernetes. But one of the things they had was the ability to kind of define not only the policies with respect to, how big your tenants can grow within a given dimension, be that tier or whatever else, but what happens when they exceed those, right? And so it was a very cool demo. If you haven't checked that out, Todd, you should go look at that.
Yeah, I think we should have, if we can get those folks to come and do a demo.
Oh yeah, that'd be awesome. Yeah,
that would be awesome. I think that would be cool.
Yeah.
I did want to pose one question related to the serverless side of this, which is API gateway and serverless are sort of intertwined in that most people who are, well, not most, but many people who are consuming Lambda functions are consuming them via the API gateway. And we talked about like having microservices implement their own throttling policies. Well, you can certainly deploy a Lambda function with a concurrency, but that isn't really in the code of the microservice. So to me, for serverless, I was trying to ask myself whether there's anything I would do differently in the way that I wrote the actual Lambda function to implement any kind of throttling. And maybe that's more around the services I'm calling from my Lambda function more than the entry point. But it feels like API gateway, concurrency, all those other sort of mechanisms already kind of are my throttling strategy. There's no more to do there. And that's maybe kind of obvious, but I guess I'm curious. We didn't have that discussion.
It's fair. I have seen some customers who actually pass all of their Lambda calls back through private API gateways too. To try to create that same effect of, rather than having your individual Lambdas be aware of throttling or any other of the functionality of API gateway. They treat them almost like they treat sidecars in EKS, right? So you say everything goes back through API gateway. When we go through API gateway, we're going to apply any sort of rules or transformation or anything else outside of our microservices.
Yeah.
And then the microservices themselves get dumber, which is actually a good thing in the microservice world. The dumber they are, the less they know about their operationalization, the better off you are, right? So I have seen that. So that's one way you could go.
What if we moved that discussion to like EC2 and you're running microservices there, or ECS or somewhere? Is there a point at which the technology stack potentially moves you to a model where, my microservice can't be so dumb, like some of this is going to have to happen inside my microservice? Or should the general goal be that all of these throttling sort of mechanisms happen somehow outside the view of the microservice builder?
I don't even know what it would look like. Like what would you do inside your service? I'm trying to picture what that code would even like.
Well, imagine you're writing a REST microservice using one of the REST frameworks, right? That is out there, right? Those REST frameworks have ways they're sort of aware of the fact that they're processing an HTTP request, and they have hooks to do things based on the fact that, like, I got to that entry point of your microservice through that path. So but how would I write code? How would I write tiering aware code? Like, what would I do differently in my code if, let's say, I had an order service? Like, what would it? I mean, it seems like all of the stuff that tiering would affect is external to the actual code that runs a service. So let's take Spring Boot, because Spring Boot's super popular, used to write a lot of microservices. It's got inversion of control and dependency injection and a lot of aspects and all these other things, right? And I could go write my microservice with Spring Boot, and apologies because I haven't done Spring Boot in quite a while, but I'm assuming I could build my own sort of policies into my general microservices framework, where each microservice I wrote would be able to detect the number of requests coming in and potentially apply throttling policies, pull tenant context out, do things to control flow into that microservice at the microservice level. So you almost kind of have like an API gateway-ish entry point to each microservice to some degree. That the tools are there to do something with it.
So
But
you're talking about like the fabric over top of them almost, and how that actually might be a function of, in your case, Spring Boot.
Yeah, I mean, it'd still be a library and something reusable, but that's what those frameworks, pre-API gateway and things, those services just got published as the API entry point sometimes of your applications. So they had hooks to do some of these things. I don't know the answer for myself yet, but I'm guessing there are ways to think about doing that there as well. So I think the bits we're sort of leaving on the table here are the dependent resources like Dynamo and SQS and Elasticsearch and whoever else you're consuming. Almost on a case by case, you're going to be saying, like, what knobs and dials do they let me have to give a different experience? And I'm going to have some notion of some kind of policies there, probably connected to tiers for some parts of my application, not necessarily for everything, but for some parts of it. And I think we still have to think more about what would an async, like fully modernized microservice model that had fallback strategies in it or more graceful handling have. I think those things are the deeper versions of this discussion that we probably don't have time to cover here, but things I would love to see our content get into. And then sounds like having some of the partners and third-party vendors in these spaces come in and share some of what they're doing would be awesome as well. But
Sure.
I think that to me, that's those are most of the things I was thinking about. Any last minute thoughts or anything you want to throw in here at the end? Go ahead.
I'll try just to contextualize some of what you just said there, because it makes me think about like headless SaaS to an extent. When I think about, usually when we're thinking about SaaS, you're picturing an end user on the other end waiting for something to happen. But throttling and tiering could also come into play if we were saying, this is a headless SaaS. There's nobody sitting there waiting for these things. So I can do more asynchronous processing, and that throttling turns into something more like a queue, where you say, okay, we're going to slow you down, and we're going to say you're only going to process so much for you at a time. So your response time is going to go down, and we'll decide how that happens. But at the same time, the other system is just waiting on a response, right? It isn't, you're not saying, hey, we're going to cut you off and return that 429. Rather, it's like, hey, your queue is so big, at some point things might fall off of your queue, but we have the ability to handle a great amount of back pressure. But your response time and how quickly let's say your images get processed, just for one trivial example,
sure.
We're going to process your images. Maybe it's going to take a couple hours if you guys start spamming us. And that's the response to throttling, is we're only going to take in so much. We're going to let queues handle that, rather than API gateways, which are going to have sort of a harder limit and say, like, yeah, we're just not going to process that for you, right?
Yeah, that's a good call out, because I think I'm mostly been thinking about this through a more binary sort of mode, which is like you're in or you're out, when in reality it could be that you're slowed, right? And that's probably a more effective strategy. If you can slow it but not break it, that means you can sort of still service the needs of people without just absolutely failing their requests. So I think that's the kind of the holy grail of a lot of these systems, right? Like Netflix, I would imagine, if they're Simian Army, right? If it's absolutely going crazy, at worst, it's a degraded experience. Yeah.
Right. It's not down, but it's a degraded experience.
Yeah, it's that bulkhead sort of model where you say, hey, if this part of the boat gets a hole in it and fills up, the boat can keep going, but we'll something of that nature. So cool. Yeah. Well, for me, it was an awesome discussion of this. Really enjoyed the kind of wandering this with you guys. I know it's an area we're still sort of getting our arms around and trying to find what the right guidance is here, but a super productive discussion, and I really appreciate it, and look forward to the next show. So thanks so much.
Awesome. Bye, everyone.
Bye.